Today we're going to learn about square roots. All right, we're going to find the square root. And so when we're talking about in example A, for example 1, when I say square root of 49, 49 is under the radical symbol. It's different than a division symbol. And it's wanting to know what number times itself equals 49. And when you see this as it's written in A, we want the principal root. The principal root is always a positive value. So we would say what number times itself equals 49, and the answer would be 7. And we know that to be true because 7 times 7 equals 49. What I said about it being the principal root, we want the positive value 7, but isn't it true that the answer to the square root of 49 could be negative 7? Because if I take negative 7 times negative 7, I still get the value 49. For this reason, mathematicians most often say that when you ask for the square root of 49, you could have either plus or minus the number 7. Because it could be positive 7, because 7 times 7 is 49. It could be negative 7. Negative 7 times negative 7 is 49. Again, we at this point only want to be concerned with the principal root. If you look at B, notice how there is a negative sign outside the radical symbol. This is because you cannot take the square root of a negative number. You would never see anything written like this. And the reason that's not allowed is because 112 times 12 is a positive 144, just like a negative 12 times negative 12 is a positive 144. In order to have a negative number under the radical system symbol, you would have to have a positive 12 times a negative 12, which then is not the same value. So that just is mathematically not even in existence. So when we see the negative symbol outside the radical, it's like saying we want the opposite of the square root of 144, or in this case, the negative 12. Okay, in example 2, we want to approximate the following square root to the nearest whole number. Now we could put this in our calculator and use that function, but we want to be able to do it without it. And since we listed and already talked about the first 15 perfect squares, we know that the square root of 150 is going to fall somewhere in between the square root of 144 and the square root of 169. Because the square root of 150, right, is in between those two perfect squares. And when I mean perfect squares, I mean their principal root is a whole number. We could take the square root of anything, of any number, but we might get a decimal, okay? So to get a whole number, you're talking perfect squares. The square root of 144 is 12. The square root of 169 is 13. And now it is your job to decide, is 150 closer to 12 or closer to 169? Because 150 is only 6 numbers from 144 and 19 numbers from 169, it is therefore closer to 12. Therefore, to the nearest whole number, we would round it closer to 12. If you did evaluate 150 to a decimal, you get 12.2, which again does round down to 12. Solving equations with square roots. If we are told that x squared equals 4, as in part A, we are basically wanting to know the value of x to make it true. So what number times itself? Remember, we have evaluated exponents before. We have done this in class. We know that x squared is truly x times x. What number times itself equals 4? You can use some mental math there to figure that out. Since 2 times 2 equals 4, we can say that x equals 2. Basically, what we've done is used an inverse operation. The inverse operation for squaring a number is taking the square root. So to get rid of the exponent of 2, we take the square root of both sides. And if you put that in your calculator, 4 with the square root symbol, or if you have to put the square root symbol first and then 4, you would get the 2. So we would do the same to the next one. Y squared equals 81. This is pretty easy, isn't it? If we take the square root of both sides, we would get y. I'm going to put that radical symbol still in that second level so that we know that that's coming out. So we get y over here. And then the answer would be 9, because the square root of 81 is 9. What times itself equals 81? The answer is 9. And finally, a little bit of this two-step equations with roots. We did do a little bit of two-step equations when we were solving for some of the missing angles inside of a quadrilateral. So when we see an equation that has something squared and then either added or subtracted, the first thing we want to get rid of is the added or subtracted number. So when you do the opposite of subtracting, oops, let's try this again. If we use the inverse operation of subtraction, we are adding 37 to both sides. And then w squared equals 144. What times itself equals 144? Last step, square root of both sides equals 12. For part B, we will undo the addition first by subtracting 17 from both sides. And we get f squared is equal to 36. And again, take the square root of both sides so that we get f is equal to 6.